Hi everyone, we're moving on now to the very first lesson of our new unit, and that is going to be on volume. Volume is something that no doubt you've come across before, probably in a math class, and maybe even in a science class, and there's no doubt it has applications well beyond the school environment. So hopefully much of this will be familiar, and we will be looking at volume, and we will be comparing it to capacity in a lesson or two here. So what is volume? The volume of an object is the amount of space it occupies, okay? There are specific formulas used to find the volume of different geometric solids. Now, just so you know, in this lesson, primarily, we will be focusing on rectangular solids, or maybe more like a cube or rectangular prism. Just as area is expressed in square units, volume is always expressed in cubic units. That's a good point. I'm sure you've been told this many times before, that when you determine volume, you must put something like, it might be in centimeters, but you got to put that cube, because volume is in cubic units or in 3 dimensions. You might have kilometers cubed. The point is, when you go through and let's say you figure out the volume and you just put 50 or put 50 centimeters, that does not communicate volume. You must have that cubed up there, and that communicates volume. Now, one thing to keep in mind here is that, of course, volume can be in different units. So you have centimeters, inches, meters, it can be anything, miles, cubes, so on and so forth. In equations, the symbol for volume is a capital V, okay? So people typically go like, V equals 25 meters cubed. So they know the capital V there stands for volume. Now, let's look at an example here. It says, calculate the volume of the rectangular solid below. Now, the formula for volume of a rectangular solid is going to be volume, capital V, L, W, and H. In other words, length times width times height. And you can see that right there. Now, of course, we're going to identify the length, the width, and the height, but it should be pointed out that, if you were simply to type these in the wrong order, you would certainly get the right answer. But just so you know, when we consider this shape, the bottom across, the line across the front bottom is considered our length, okay? The side kind of on the bottom that kind of goes between the front and the back is called your width. And the line kind of up and down determining how far you are off the ground is your height. So when you do this properly, your first step is always to write the blank formula. Step 2 is to input your values. So you would go 15 meters by 6 meters by 12 meters. And you simply calculate that out, and that will give you 1,080. And it is going to be in meters, and it's meters cubed, because that's volume. Another way to think of it is, and this is in other math course, but look, how many m's did we have? 1m, 2m, 3m's. So that's why we get 3m's right there. So it's 1,080 meters cubed. That is the volume of that shape. Now, that seems pretty easy, but what I need to make you aware of is that quite often the ability to convert between different measurements is going to come in very, very handy. So you are going to want to have close by you a formula sheet or some way of converting from one measurement style to another. Let's look at example 2. Bob runs a landscaping business. He needs to cover a garden that is 10.8 meters by 9.5 meters. With 10 centimeters of topsoil. So it's interesting here. Essentially what we have is we're probably going to have a rectangular cube here again. Okay. And the problem being, so let's see here. He needs a cover garden that is 10.5. Okay. So let's go 10.8 meters there. Let's go 9.5 meters there. And it's interesting because it's 10 centimeters deep. Well, you see the conflict here is meters, meters, centimeters. Those don't work. So you have to be able to convert this into a consistent unit, probably either into meters or into centimeters. But if you look at this, it says, what is the volume of topsoil he needs? Okay, so that's one thing. We're going to find the volume. Now you should be thinking to yourself, okay, well, I could put this all into meters or into centimeters. But here's the hint. If soil costs $18.75 per meter cubed, you see, that's kind of going to be your hint. The money, the unit price in this case, is in meters cubed. So my advice to you is change that 10 centimeters into meters. So 10 centimeters, if you divide that by 100, is 0.01 meters. Now the ability to convert measurements was done in a previous unit, and I have to move forward kind of with the understanding that you can do this, you're proficient at it now. Now I know that this is 0.01 meters. Now we can calculate our volume. Volume is length times width times height, 10.8 meters times 9.5 meters times, oh sorry, I need to put an X down there, that's certainly in the wrong spot, times 0.01 meters, and that's going to give you 10.026 meters cubed. That is going to be your volume. And again, if you look at it, I put everything into meters, and remember, I put meters cubed. Now, to answer the final question, it says they want to know how much is this going to cost. Well, we have a unit price here. We know that it is $18.75 for each meter cubed. So that means if you had 1 meter cubed, it would cost you $18.75. If you had 2 meters cubed, you would simply go 18.75 times 2. Well, in this case, we have $18.75. We're going to simply multiply that by, let's see here. Well, let's not worry about the rounding too much. You can certainly just go times 10.26 meters cubed, and you will get a price in this case, because I don't see where it says about the rounding. So 18.75 times 10.26, and that will give you, give or take, $192.38. Now, I'm not making a mistake here. You just notice that what they've done here is they've rounded the 10.26 to 11. And I don't see anywhere in here where it says that you need to round, so I'm going to give you the exact answer. So again, here is your volume. Here is the cost. It's a two-part question. This involved maybe drawing out a shape. It ensured you had to make sure that all of your measurements were in the same unit, because we had a meter, and a centimeter. Once I had converted the centimeters to meters, then I could carry out the volume calculation, and so on and so forth. That's going to be kind of the main part of this lesson, is the ability to change in between different measurements. Now, we'll keep going here. As with square units, cubic units for volume can be converted within a measurement system, metric or imperial. To convert within a system like meters cubed to centimeters cubed or inches cubed to feet cubed, first change the radial. Okay, that's getting really, really wordy here now. So let's do this an example and we'll see what we mean. Example 1, a hay bale measures, so we are going to be 15 inches by, I have to make this a cube, sorry, by 24 inches by 36 inches. What is the volume of the bale of hay in cubic inches and cubic feet? Well, if we're already in inches, so volume is length, width, height. So you would go 15 inches times 24 inches times 36 inches, and that would give you a value of 12,960 inches cubed. Great. But that's only part of the question. They also want this in cubic feet. Now again, you should have your formula sheet with you. But it's nice to know here that, and we have done all this before, there's no big deal here. This was covered in a previous unit, that we know how to change inches into feet. Okay, so if you take the 15 inches and you divide that by 12, that will give you 1.25 feet. If we take the 24 inches and divide that by 12, that will give you 2 feet. And if you take 36 inches and divide it by 12, that will give you 3 feet. Now you simply can carry out your volume measurement, length times width times height. So that's going to be 1.25 feet times, I'm running out of room here, sorry, 2 feet times 3 feet. And that's going to give you 7.5 feet cubed. Okay, all we did there is convert a measurement. Then what you're going to see here is in the bottom, it's kind of the same thing. You're given something in centimeters and they want it into meters. The point is, the math is not hard, but you must read the question carefully and know how to convert units. Okay, let's give you some practice with this concept.